Welcome back to the second video on electron configuration. I am starting this video off with an assignment. I want you to identify the following 5 elements shorthand electron configuration. I want you to do K, that's potassium. I want you to do promethium, element 61. I want you to do osmium. I want you to do sulfur, and I want you to do lutetium. Pause the video and write out these shorthand electron configurations real quick. All right, let's start with potassium. Potassium is in the S subshell, so it has to have an S. To figure out the coefficient, the large number in front, we count down. 1, 2, 3, 4. So this is 4S. To get the exponent, we count over. So it's in column 1, so it's 4S1. Okay, then we have promethium. Promethium is in the F block, so it's going to get an F. It is in the first F block row, which is period 6, but that is not the number that the F blocks or the F subshell starts on. The F subshell starts with 4. So it is 4F, and to get the exponent, we count over 1, 2, 3, 4, 5. So exponent 5. Now, osmium. Again, this is the D block. Or sorry, that's the D block. And again, the D block does not start at 4, even though it's on period 4. It starts with 3. So when we start counting down, we start with 3, 4, 5. So this is 5F. And then count over 1, 2, 3, 4, 5, 6. So exponent 6. And that 6 is hard to see, but it's there. Then we have sulfur. Sulfur, same thing. Sulfur, P. P block, same thing. We start counting with 2, 3. So this is P block, row 3. And it is the 4th in the column, or the 4th column over. That brings us to lutetium, the last one. Lutetium, I tricked you, or I tried to. Hopefully it didn't work, because lutetium is not actually right here. Lutetium is right here. So it is in the D block, not the F block, and it is in 3, 4, 5, D1. So hopefully you got those correct. I would go through and correct them if you did not, so that you have the correct answers for later. Today, what I want to focus on is a longhand electron configuration. And the first thing we have to do there is get rid of this periodic table. We need to go back to the blank page. So I'm going to do that real quick. So this is your last chance to pause this to get these checked real quick. Gone. Okay, let's do a longhand electron configuration. Longhand electron configuration writes out every single subshell that an atom has, or an element has. So the first thing I'm going to do here is I'm going to add back in this column that I had to erase. And that is just the 1s subshell. Now, our longhand electron configuration, we're going to write in. I would encourage you to write this out on a sheet of paper. If you can color code it, do. And then I want you to take a picture of it and post it in your notes under longhand electron configuration, so that you have a photo of what a longhand one looks like. I would not try to type it because it's going to have lots and lots of exponents in it, and that's going to get real tedious real fast. So I would just write it out neatly, legibly, and on one line, not two. And then you'll be able to take a picture of it real quick and just paste it in. So you won't have to worry about it. Crop it so you don't have a bunch of useless crap in there. Now, the first subshell, we're doing lead, by the way. Neutral lead. The first subshell that has to fill is going to be the 1s subshell. Now, since we are doing lead, which is going to have 82 electrons in it, the first several subshells are going to be completely filled. So we do not have to write 1s1, 1s2, 2s1, 2s2. We just write the filled electron notation, the filled shorthand. So, the first subshell is the 1s subshell, and it is going to have 2 electrons in it. The next subshell is the 2s subshell, which also has 2 electrons. Then, the next one we're going to come to is the 2p subshell, which is going to have 6 electrons in it. After 2p, we go back to s, but 3s. So 3s2, 3p2, no, not 2, I'm writing the wrong thing, 6, because it holds 6 electrons, that's the max it can have. Then back to 4 for s, which is going to have 2. Then we hit our first d subshell with 3d10. Now, at this point, we have accounted for almost half of the electrons in lead. And it's going to go faster as we get higher because we're going to have more of the larger subshells. So after 3D comes 4P. So 4P6. Then we're back to 5S, which is also going to have 2. And this is the point where I'm going to tell you, you need to be looking at your periodic table. We are currently at strontium, element 38, which means we have done, we're getting really, really close to half the number of electrons. Okay? So the next subshell is going to be 4D10. And at this point, we're past the halfway point. After 4D10 comes 5P6. Then we're back to an S with 6S2. So now we're looking at barium. So then next is going to be an F subshell. We need to go down for the lanthanides. So that's going to be 4F14 because all of those electrons are going to be filled. Then we have our D subshell, which is going to be 5D. And that's going to have 10 electrons. Now, at this point, right now, we have 80 electrons accounted for. And you can figure that out by counting up the exponents, or adding them all up. You'd get 80 from what's up here right now. So our last subshell is going to be a P subshell. But it is not going to be full. Okay, it is not going to be a full subshell because we only need 2 more electrons. So it is going to be, 6P2. Now, an attentive student might notice that 6, I'm not going to write that there, that'd be silly. 6P2 is the shorthand electron configuration for lead. The last character, the last section of the longhand is always the same as the shorthand. There is another version of shorthand here, which you'll probably encounter in college, which I'm not going to bother going through. But that's how you write a longhand. You just fill out all of the electrons for everything. So I want you, this is the part you need to take a picture of and put in your notes, by the way. Ditto for this. I want you to go ahead and write out a longhand electron configuration for phosphorus. That's element 15P. I want you to write that out on your own. Pause this, write that out, and then come back, and I will walk through making it. Check yourself. If you're not checking yourself, you're not going to know if you actually get it. So try it. Take a crack at it. All right, so we're going to go through phosphorus now. I'm going to work this out. Phosphorus has 15 electrons, so our exponents should total 15. So again, our first several subshells are going to look exactly the same. We have 1s2, 2s2, 2p6, and then we're going to go back to 3s2. I am looking at the periodic table, by the way. If you're wondering why I keep turning and looking that way, that's my big periodic table. I'm looking at it since I can't put the periodic table on the board right now, which would be super convenient. Now, at this point, we have made it to the block and row that phosphorus is in. So the last piece of this is going to be 3p3. And that's it. That's the end for phosphorus. That's the whole longhand. All of the longhands look the same after a while. But that's as far as we're going to go. And this is where I'm going to stop it. I usually use the Bohr diagram to try and help people to come to understand it better. But I don't think that's going to be necessary this year. So I'm not going to draw that out. It's kind of tedious anyway. So we're not going to draw out the lead Bohr diagram. Unless somebody gets a hold of me and says, hey, I really need to see this. In which case, I will make a third video drawing that out and explaining how that works. So, that's it for this. I hope this helps. If you are having trouble with electron configuration, if it still does not make sense at this point, then you should comment on the video, send me an email, get a hold of me through Parent Square, something, so that I can try to help you out with this. You don't have the benefit of asking questions like everybody in class does, so get a hold of me if you get stuck, and ask the questions there. Okay, that's it for this video. I'm going to call it here. Hope this helps.